visible? Hello? Okay, fine. See, this is a PPT from your book Forozen. The topic is digital signature. So, see, we are all in last lecture. I have discussed about this digital signature concept, the brief overview that I have given. So, we all are familiar with this concept of signature. A person sign a document to show that it is originated from her or was approved by her. So here you can say that the signature is the proof of the recipient that the document comes from the correct entity. Here, let's say I can say that when customer signs a check, the bank needs to be sure that the check is issued by that customer, no and nobody else, right? So you can say that in other words, you can say that the signature on a document, when verified, is a sign of authentication. The document is authentic. Another example, consider painting that signed by an artist. So the signature on the art, if authenticate, means that the painting is probably it is authentic. So now in our this particular chapter, all of you know that the two entities that you have to remember, one is a Alice and another is a Bob. So let's say when Alice send a message to a Bob, the Bob need to check the authenticity of the sender, right? He need to be sure that the message come from Alice, it is not come from Attica. Let's say I can say the name Eve, right? So there are two party, one is a Alice and Bob. When Alice sends a message to a Bob, the Bob need to check the authenticity of the sender, and he needs to be sure that the messages come from the what Alice, right, not Eve. Now, Bob, what the Bob will do? The Bob can ask her allies to sign the message electronically, right? In other words, the electronically signature can prove the authenticity of the allies as a sender, right? And we refer to this type of signature that is a digital signature, right? So this is the just brief overview of digital signature. Now. Let's begin with the differences between the conventional signature and another is a digital signature. So let's start with that. So what is conventional signature? So a conventional signature is included in the document. It is a part of the document. So simply we can say that when we write a check, a signature is on the check, right? It is not a separate document. But when we sign a document digitally, so sorry, we send the signature as a separate document, right? So here you can say that the sender sends two documents. One is a message and another thing is what? Signature. So on the receiver side, what happened? The recipient receive both the documents and verify the signature belongs to the supposed sender, right? And if this is proven, then you can say that the message is kept. Otherwise, the message is rejected, right? So this is the difference between conventional signature and digital signature. Now, see here you can say that for a conventional signature, what happened when a recipient, sorry, hello, uh, hello, my voice is clear. Hello, Abhi, okay, fine. Okay, now listen. For a conventional signature, when a recipient receives a document, right? What he or she will do? She compares the signature on the document with the signature on a file. See, this is the case with what conventional signature. Because on a conventional signature, you can say that it is included. The signature is included in the document. It's a part of the document, right? So, in the case of conventional signature, what happened when the recipient receives a document, she compares the signature on the document with the signature on a file, right? If they are same, then you can say that the document is authentic, right? But in the case of this digital, what happened? So in that case, the recipient, see, in the case of conventional, what happened? The recipient needs to have a copy of this signature on a file for comparison, right? This thing is needed for what? Conventional. But in the case of the digital signature, the recipient receives the message, and another thing is what? Signature, both the things. Now what happened? The copy of the signature is not stored anywhere. So the recipient needs to apply which technique? Some verification technique the recipients apply to the combination of message and signature to verify the authenticity. So this is the case. In the case of digital signature, it is done, right? So up to this clear, is there any doubt, everyone? So see, these are just difference. I will explain you, that is what's the conventional and what is the digital signature. Is it clear to you all up to this? Please reply so I can understand. Okay, fine. Now, the another thing that between this conventional and digital, you can say that for a conventional signature, there is normally a one-to-many relationship, right? Between the what? Between the signature and a document. So see, here I can say that, for example, you can say that a person uses a same signature to sign many documents, right? A person uses the same signature to sign many documents. But for a digital signature, what happened? There is a one-to-one relationship between a signature and message. So each message had its own signature. The signature of the message cannot be used in another message. The signature of the message cannot be used in another message. Now see, suppose let's say I can say that if Alice and Bob, there are two parties. Now if Bob receives a two message one after the another from the allies, then what happened? He cannot use the signature of the first message to verify the second, right? Each message needs a new signature. So again, I repeat, for a conventional signature, it's a one-to-many relationship. A person uses the same signature to sign many documents. But in the case of digital signature, one-to-one relationship between the signature and message, right? If the Bob receives the two message one after another from allies, so in that case, you can say that he cannot use the signature of first message to verify the second, right? So here you can say that each message needs a new signature, right? So this is the difference between conventional and digital signature. Now, the another difference, that is, in a conventional signature, the copy of the signed document can be distinguished from the original one, right? Yes or no? So that thing happened. But in the case of digital signature, what happened? So there is no such distinction unless there is a factor of time on the document, such as a timestamp on the document. For example, I can say that Alice sends a document instructing a Bob to pay Eve. If the Eve intercept the document and the signature, and she can replay it later to get the money again from the Bob, right? So these are the difference between conventional signature and digital signature. Is there any doubt? Is there any doubt up to this? Is it clear to you all? Hello? Can you hear me? Okay, clear? Right. Fine. Now, the next point, that is, uh, what is the how the what is the this digital signature process? Now see this figure everyone. So here in this case, what happens? See, Alice is a sender and Bob is the receiver. Okay. So now, in this process, what happened? The sender, Alice, the sender uses this signing algorithm to sign the message. This is the original message. So what the Alice sender uses? Sender uses this signing algorithm to sign the message. And then what happened? The message along, see, after this signing algorithm, what you get? You get the, in sender side, get the signature. Now then after what happened? The message along with this signature are sent to the receiver, Miss Bob. So now what the Bob will do? What the Bob will get? The receiver that receives the message and signature. And then what the receiver will do? It apply the verifying algorithm to this combination message and signature. And if the result is true, then the message is accepted. Otherwise, it is rejected. See, these are generalized process that I have discussed. In next figure, I will explain you in detail how exactly it works. See, normally this thing is done here on sender side signing algorithm is there. Based on that, in sender side signature, you get the signature. Then the message along with the signature, it is passed to the receiver. And then on receiver side, what happened? The verifying algorithm is applied to this combination. And then after, if the result is true, then the message is accepted. Otherwise, the message is rejected. So in this way, the whole digital signature process works. Right. Now, in detail, how it works, that I will explain you. Okay. Now, see here, in this digital signature, what happened? These are sender, or I can say that the signer, right? The signer, what the signer will do? The signer using Alice is a signer. The signer uses her private key, right? Her private key, and you can say that that is applied to a signing algorithm to sign a document. Now, the verifier on the other hand, what the verifier will use? So the verifier uses the public key of the signer, right? So with the help of that, you can say that it is applied to a verifying algorithm to verify the document. So remember here what happened. First of all, the sender side, whatever the message is there, using the Alice private key, the signer using its own private key by, and it is applied to a signing algorithm. And finally, what get it? The message along with this signature, that is send it to the receiver. On receiver side, what happened? The receiver side, in our case, it's a Bob. So what the Bob will do? The Bob uses the Alice public key, and with the help of public key, what the Bob will do? So now it applied to this verifying algorithm, and then finally here in this side, what the Bob get? So here see what the Bob will check in by using this. So here message, and then here what you get? So the signature is there. So by using verifying algorithm, see here, it check that whether the result means you are getting the same messages or not. If the result is true, then I can say that the message is accepted. So now by using what you check, so that means here in this case, see, in previously in first lecture I explained you that the Bob can fool the allies, but see here the allies sure that allies says that okay, this key is from my side. Okay, I have sent this key. Clear everyone? Is it clear to you all? The Bob can't fool the allies. Is it clear everyone? Hello, can you hear me? Is there any doubt? Okay, fine. Okay, now another thing that I want to tell you, that is, see, when a document is signed, including the Bob, including the Bob can verify it because everyone has its access to Ali's public key, right? So here you can say that See here the allies public. See, these are public, right? So anyone can use that public key. Okay. So now my one here the question is, see, first read this point, that is a digital signature that needs a public key system. The signer signs with her private key, and the verify with the signer's public key, right? All of you know that. Now, one question I want to ask, that is, can we use a symmetric key to both sign and verify a signature? All of you know the symmetric key concept, right? So, can we use the symmetric key to both sign and verify the signature? Please write down in the chat window. Again, I repeat, my question is, can we use the symmetric key to both sign and verify the signature? Can you hear me, everyone? Please reply. Hello. Okay, so now see here in this case, you can say that the answer is negative for several reasons. Why we are not using, see, it's a negative, but which are the reason, right? We are not using the symmetric key. So the first, that is, see, the secret key is known by only the two entities. In our case, the allies and Bob, right? So now what happened? If allies need to sign another document and send it to the TED, then what happened? C needs to use the another secret key, because see, right now suppose my symmetric key is shared between Alice and Bob. Okay, but suppose then what happened? Alice and Bob, both the party can communicate. But suppose Alice want to communicate with the Ted, then what happened? Again, she need to create another secret key. Priyank, symmetric key means combination of private and public. What is the concept of symmetric key? I am talking about the secret key, right, which is shared between both the party. And asymmetric key means public key crypto system. You know that. Yes or no, Priyank? Priyank, can you unmute yourself? No, no, Priyank. Yes, sender and receiver both share the same key. That key, see, they meet somewhere and they decided this is the key, right? When we combine this key we are using. Okay, that is the concept, right? Yes or no? Is it clear to you all, Priyank? Is it fine?
Hello, ma'am.
हाँ बोलो.
Uh, I am talking about what is the difference between symmetric key and private key.
See, each and let's say in public key crypto system, what I am suppose, let's say in this digital signature, why in digital signature? First of all, tell me this thing, right? So Alice uses its private key, right, for signing the algorithm, and then Bob's side uses the Alice public key. Then what happened? Can you tell me this scenario, Priyank? Can you explain me that scenario? Why we are using the concept of digital signature? Because see, in second lecture I have explained you, suppose I am not using this private key public key concept. Okay, suppose let's say the key is shared between both the party Alice and Bob. You assume that scenario, right? So now what I'm trying to say is, a symmetric key means both the parties share this common key. Now, in that scenario, what I explain you, that is, suppose means Alice sent some message to a Bob, right? So, means hashing and all that concept that I've explained. But later, it may be possible that the Bob have that key. So again, Bob encrypt the message and then encrypt it. But and at that time, so what happened? My message is modified, but later the Bob tells that okay, this message is sent by Alice. Means in this way, the Bob can fool the allies. But now, when the message is in this allies side, when the allies private key is used and that the Bob decrypt with the allies public key, so in this public key crypto system, what happened? The Bob can't fool the allies. Allies says that okay, I have sent this message. Now, got it? What I'm trying to say, Priyank? Hello, Priyank. Please unmute yourself.
Yes, ma'am.
Right, and private means its own key, private key. Got it? And that's why the digital signature comes in picture, because that scenario already I told you, that non-repudiation, yes or no?
Yes, ma'am.
Right, so that concept that I have explained, that's why this digital signature comes in picture, right? That whole scenario that I have discussed. So, see here, what I told you that now my question is, can we use the secret key to both the sign and verifying the signature? So here I can say that the answer is negative for several reasons. So what reason that I have explained? Suppose let's say the secret key is means secret key, or I can say symmetric key. If it is not between only two party allies and Bob, but suppose I want to suppose allies need to send the allies need to sign another document and I want to send it to the some another party. Instead of Bob, I want to send it to the Ted. Then what happens? So if the allies want to communicate with Ted, then again she needs to use the another secret key. Got it? What I'm trying to say? And another is creating a secret key for a session that involves authentication and which uses a what digital signature. And the third case that is, I can say that the Bob could use the secret key between himself and allies, sign a document, send it to the TED, and pretend that it came from the allies. Right? So that thing also happened, right? That scenario also I have discussed in that your second lecture. So that's why you can say that the digital signature that needs a public key system, the signer sign with its her private key and the verify with the signer's public key. So this is the concept of what digital signature. So here you can say that, see, the authentication is achieved. So here allies says that this message is sent by me, the Bob can't fool the allies, right? Got it? Now another system is another one point that I have written, that is a crypto system that uses a private and public key of the receiver. A digital signature uses the private and public key of the sender. See, in earlier I told you that, see, also in RSA crypto system, right? RSA crypto system that I have explained. So in RSA, what I have explained, see, this is the, I think, third or fourth lecture I have explained about this RSA crypto system. So in RSA crypto system, which scenario that I have discussed, if allies and Bob, there are two party. If allies want to send a message to a Bob, then who perform the setup? Please reply in the chat window, everyone. If allies want to send a message to a Bob, then who performed the setup? Receiver performed the setup, right? And then what happened? Yes, Miss Bob performed the setup. And then after what happened? What the allies will do? What the allies will do? So the on Bob's side, the public and private key is generated, and with the help of Bob public key, the allies encrypt the message. Now read this point, everyone. The crypto system uses a private and public key of the receiver, right? Because with the help of the public key of the receiver, the sender, what sender encrypt the message. All of you know that. And on receiver side, the receiver what uses? Receiver uses its own private key. Now, while in the case of digital signature, what happened? The digital signature uses a what private and public key of the what sender. So this is the difference that you have to keep in mind. All of you clear? Is it clear to you all? Hello? Okay, fine. Now, see, normally here, see, I have explained you that the hash function. Now, please write down in the chat window, what is the use of hash function? Why we need hash function? Please write down in the chat window, what is the use of hash function? No. Yes, Prince, you are correct. To ensure the data integrity. So what is the use of hash function, Prince? If I am using the hash function, then what happen? Basically, for which purpose we are using the hash function? To ensure the data integrity is fine, but to what? To verify. See, all of you know that when I'm using the hash function, then message digest is created. Yes or no? So basically, normally what happens? So if the message is of variable length, means if my message is very large, right? So in that case, what happens? So if you are directly applying the encryption, right, then that process becomes costly, right? So that means you can say that what you have to do on a large message, first you have to apply the hash function, and when you apply the hash function, then what you get? You get the fixed length, right? You get the message digest of what? Fixed length. All of you know that the message is of variable length, but when you apply the hash function, like you can say that sha512, that already that I have discussed, sha512 md5, then after applying the hash function, what you get? You get the message digest, right? And that is a fixed length, right? And Prince, you are correct to ensure the data integrity, right? So here you can say that see, on receiver side, if the both the hash data are compared, then you can say that the message is not modified, and in that way you can say that the integrity is achieved. All of you know that, right? So now see here in this case what happened. See the same scenario, but here what I have used. So directly on message I am applying with the help of Alice private key. It is applied to what? Signing algorithm. But now here I have to assume that, see, normally this scenario is there. So just you have to remember that in a digital signature, the messages are normally very long. And that's why we have to use this asymmetric key, and the solution is to, so that's compulsory, the hash function is used in the case of what? Digital signature, because the messages are very large. So here in this case what happens? Whatever the message is there, on that first the hash function is applied, and when the hash function is applied, all of you know that the digest is created, right? So now here you can say that the digest is made out of the message, right? Out of the message at allied side. Now what happened? The digest then goes through a what? Signing process, using what? Using the allies private key. Now then after what happened? The allies then sends a message and signature to a Bob, right? This thing is happened, and generally the message and signature, normally the separately they are sending on a channel. Okay, so now it is sent to the Bob side. Now at Bob side what happened? So uses the same hash function, right? Whatever the message is there, uses the same hash function. So now when applying the same hash function, so here what? The digest is created, right? The digest is created, and then what happened? A digest is first created out of this receive message, and the calculation are done on what? The signature and the digest. On that the calculation is done. And what this verifying process will do? The verifying process, here you can say that it also apply the criteria on the result of calculation to determine the authenticity of the signature. So now here in this case what happened? So now see here on hash, the signing algorithm is by using Alice private key, the signing algorithm is applied. So what you get? Signature. Again by using the Alice public key, Alice public key is using. So here after this algorithm, here you are getting this hash code, and here from this message you are getting this hash code. Both the hash code are compared, and both the hash code are compared. That means you can say that the message is not modified. That means in this way you can say that the integrity is also achieved. The integrity is achieved. And see, also here the Alice private key is used. That means you can say that the two things are achieved: authentication, and what another thing is integrity is achieved. So again, I repeat, here in this case, what happened? The a digest is made out of the message at the Alice site, right? The digest, the digest then goes to the signing process using the Alice private key. Now Alice then send the message along with the signature to the Bob. On Bob side what happened? At the Bob side uses the same hash function, right? So the digest is created over here, Now here what happened with the help of Alice public key. So when it applied to the verify algorithm, what to get here also you are getting hash. Now digest you are getting both the digest are compare, and when it is compared, then you can say that when it is compare, that means you can say that it is the message is accepted. So all of you clear? Is it clear to you all? Is there any doubt? Please reply. Hello. Is it fine, everyone? Can you hear me? Hello. Okay. And see, listen, everyone. Normally, in digital process, see, not this one. Okay. Normally, the message is very large, so that's why signing the digest, this structure is used. Whatever the message is there, first hash function is applied, and then after Alice private key, the sign it applies the signing algorithm, and then you get the signature. So this thing is done, right? So that you have to remember. Now, so see here one point that I have written, that is a secure digital signature scheme like a secure conventional signature can provide a digital signature provide a message authentication, right? Because see the already through this figure that I have explained, what I have explained, because in this scenario what happened, the Bob can verify that the message is sent by allies because the allies public key is used for verification, and the allies public key cannot verify the signature that is signed by a Eve's private key. Let's say some attacker Eve is there, right? So the allies public key cannot verify the signature signed by, suppose, let's say some attacker Eve. It's private key, and that's why here by using this structure you can say that the Bob can verify that the message is sent by allies, and that's why I have written this point, that is the digital signature that provide the message authentication, right? And the another thing, one point, see that the digital signature that provide a message integrity. So what I when why I can say that, because the integrity of the message is preserved even if we sign the whole message, right? But because we cannot get the same signature if the message is changed, right? We cannot get the same signature if the message is changed. So the digital scheme today use a hash function in a signing and verifying the algorithm that preserves the integrity of the message. All of you know that here the hash algorithm is used, and finally what happened, so this the original message on that hash is applied, and see here after this whatever the here on both sides, so both the hash are compared, and both the hash are compared, then you can say that the message is not modified, and that's why you can say that the integrity is achieved. So this, by using this, you can say that the digital signature provides a message integrity, right? So all of you clear up to this? Is it clear? Okay, fine. Okay. Now the next concept is non-repudiation. So see, first I will explain you a scenario. So if allies sign a message and then denies it, right? Can Bob later prove that the allies actually sign it, right? For example, I can say that if allies sends a message to a to a bank, let's say I can say Bob. Okay, so if allies sends a message to a Bob and asks to transfer rupees 10,000 from her account to a Ted's account, right? Now, can allies later deny that she sent this message? So, with this scheme we have presented so far, the Bob might have a problem. So, here you can say that the Bob must keep the signature on the file and later use the allies public key to create a original message to prove the message in the file, and the newly created message are the same. So this is not feasible, because here you can say that in this case, the allies may change her private or public key during this time. So she also claimed that the file containing the signature is not authenticate. And that's why one solution is, see here, first of all, Alice sent this message to a Bob, but after some time, she denied that, okay, I have not sent this message. And meanwhile, meanwhile, it may be possible that Alice changed its private or public key or something, right? So here in this case, you can say that the solution is a trusted third party, right? The people can create a establish a third party among themselves. Okay, so now here in this case, what is the concept of this trusted center? See, first of all, what happened? The allies create a signature from her message. This is the message, right? And what happened here? Use the allies private key. Okay, so allies create a signature from a message, from her message. That means, and the signature, that is SA, CM, and SA. Okay, and then message sends the message and her identity, right, and the Bob's identity, and and the signature to the center. Again, I repeat, everyone. The allies creates a signature